Gentlemen, welcome back. Now that we're getting comfortable with segment addition and all of the different pieces, now we're going to move on to distance. Distance we talked a little bit about in segment addition, but now we're going to get whole hog into distance and realize that there's actually a formula for that, and it's kind of low-key the same formula that you're going to be using on all of these topics. All right, so first things first, there's the formula. I'm not going to say anything for a couple seconds, so you can hit pause and copy this in your notes right now. Okay, so now that you have this copied down in your notes, the first couple of topics we can cheat a little bit because you can see how your vertices, your points, your coordinates are stacked right on top of each other, or they've also been known to sometimes been given horizontally. Because they're on a straight horizontal, or in this case, a straight vertical, that actually makes it easier for you because all you're doing is basically counting because effectively it's just a number line. So in this particular case, when you're looking for the distance of KL, what do you have? How many places do you jump? 1, 2, 3, 4, 5. Your KL over here is 5. From A to B, what's your distance going to be? How far are you going? Let's see here. We go over 1, 2, 3, 4, 5, 6, 7, 8. So we're going over 8 spaces, okay? But what happens then if they don't give you a graph where you can like very easily get your, do your counting? Well, that's where this formula starts coming into play. So what we're going to do, you can see here that they gave us 2 numbers. We're going to do some labeling. So that's going to be x1, y1, x2, y2. And now we are all set to label our formula. So of course I have to rewrite it. So it's going to be x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay, did it without looking. Now all we're doing is filling in our numbers. So what is our x2? 4 minus, what is our x1? 4 squared plus, what is y2? 5 minus, what is y1? Negative 6. All right, double negative makes a positive. 4 minus 4 is 0. So that's 0 squared plus 11 squared. And if any of you guys are coming into geometry through Algebra 2, this should simplify automatically for you because you remember that squares and square roots undo each other. But if you're coming in from Algebra 1, let's double check. The 0 completely disappears. So you're left with root 11 squared, which is root 121. And what's root 121? 11. And since I have an Algebra 2 snob somewhere who's going to say, but Miss, isn't it negative 11? I remind you that distance is always positive. So there, haha, I win. Distance equals, let's see here, there's x1, y1, x2, y2. So what is my x2? 2. What is my x1? 7 squared plus. What is my y2? 3. What is my y1? 3 squared. So distance equals root. What is 2 minus 7? Negative 5 plus 0 again squared. So this topic, do you see how it says they share a common coordinate? That's going to happen every time in this topic. So what are we left with? What is negative 5 squared? Negative times a negative is 25. So what is root 25? 5. All right? Well, what if they don't give you a common coordinate? That's what this one is, right? So what do we have? x1, y1, x2, y2. So what do we have is going to be x2, negative 9, minus x1, negative 1, y2, which is 2, minus y1, which is negative 6, squared. And I'm going to take a note on something. See how it says exact answer? That means this is not going to divide evenly, so we want to keep that in mind. When we do this out, double negative is a positive, double negative is a positive. Negative 9 plus 1 is negative 8 squared, plus 2 plus 6 is 8 squared. So that's going to be 64 plus 64, which is 128. Now, for those of you who come in through Algebra 2, this is stuff you were doing in Goal 4. But in case you forget, I'm going to cheat for you. 128, I happen to know, is 64 times 2. What is root 64? 8. Can we do root 2? No, so we leave it as 8 root 2. For my Algebra 1 students, you'll have to let me know down in the comments, can you leave root 128 and have it tell you that it's correct? If not, you have to go through this and you're going to ask one of your Algebra 1 kids, dude, hook me up, how do I do this? Meanwhile, next problem, x1, y1, x2, y2. So distance equals, what is x2? Negative 8 minus, what is x1? 0. Oh, that's easy. All right, plus, what is y2? 7 minus, what is y1? Negative 1. Double negative is a positive, so what are we left with? That's negative 8 squared plus 8 squared. Wait a second. How did we get the same thing, even though we have different numbers? Oh well. So what do we have? That's going to be 64 plus 64, which is root 128. And as we already know from the prior problem, that simplifies to 8 root 2. Now, for my Algebra 1 kids, this one, the exact answer one, might not be your favorite, but you can, however, there's no excuse in order to do decimal answers, because then you're just going to let the calculator do the work for you. So, again, x1, y1, x2, y2. Distance equals root, what is x2? 4 minus, what is x1? Negative 4. Oh, don't tell me we're going to go through it again. Plus, what is y2? 5. What is y1? 0. Oh, good, we're not. Yay. Equals 4. Double negative is a positive, so that's going to be 8 squared plus 5 squared, which is 64 plus 25, which is root 89. Let's pull out a calculator. Now, I don't have access to the Alex graphing calculator just because of how the software is working on my end, but I'm going to square root our 89 and look at that unholy mess. What does it say? It says round to the nearest hundredth. Hundredth is 2 decimal places, so 9.43. The other 3 is my decision maker, and it means I stay the same, so 9.43. So equals 9.43. That's going to be, or at least it approximates. It doesn't actually equal, but it approximately is 9.43. Next up, x1, y1, x2, y2. You're starting to realize how cathartic it is because it's just so wonderfully repetitive. 9 minus 1 squared plus, then it'll be negative 5 minus negative 1 squared. Equals, so this is going to be 8 squared. What is it with us and getting 8 squared over and over and over again? Plus negative 5, that's a double negative, so that's going to be negative 4 squared. So that's going to be 64 plus 16, which is root 90. Oh, 100. Hey, we got lucky. Our number is going to be 10. Okay, then this one, here's what's going to happen, and I didn't quite give myself enough room, but the good news is that this is the last topic of this particular video. What you're doing is you're going to go through the effort of finding the distance for all 3 of these. So you know what we're going to do? We're going to cross this one out because doing one of these hopefully will be enough. So let's see here. Let's call everything in this column x1, y1, x2, y2. So let's get ourselves a setup here. So we have x2, which is 2 minus negative 3 squared, plus y2, which is negative 4 minus, I lost my train of thought, negative 7 squared. So that is going to be what? That is going to be double negative, double negative. So that's going to be 5 squared plus 3 squared. And what is that going to be? That's going to be 25 plus 9. Let's see here, exact answer. All right, so that's going to be 34. So this one is going to be root 34. I'm cheating a little bit because I happen to know that 34 does not divide evenly. All right, so that's our first one. Let's set up the next one. What do we have? What is our x2 is negative 1 minus 2. And then it is negative 3 minus 2. No, this one's a 1. Okay, did you see what happened? Ms. Du Bois just made a mistake. Be careful about your x's and your y's. Even Ms. Dubois can be fallible. So -1 and -1 is -2. And then -3 and 2, that's -5. 2 squared is 4. 5 squared is 25. So we're looking at root 29. So this is going to be root 29. Okay, so far so good. Now we're going to go through this again. Now I'm looking at x2 for the third one. x2 for the third one is -5 minus, what do we have? -7. And then it will be 2 minus 7. So double negative is a positive. So that's going to be 2. And that's going to be 5. So that's going to be 4. That's going to be 25. And then that's going to be root 29. Root 29. And now check all of the statements. So remember, we had talked about in an earlier topic, that equal with a squiggle over it, we read it as congruent. To be congruent means the same in every way. So which distance is the same? That would be FG and JK. And JK doesn't mean that there's a joke here. That's what you're doing for this particular topic. If you want, you can ask me down in the comments whether or not you want me to do the other topic, but honestly, I just did the distance formula for you 3 times in rapid succession. I think we're good. So that is everything for Geometry Goal 1, Family 4. Now that we're comfortable with all of the segments, next we're going to talk about some of the angles. As always, stay happy, stay healthy, stay safe. I'll see you in the next one.